This is the third video on solving, and this video has something on it that's really important, and that is some special cases that we actually did not talk about in class because I was too concerned with confusing everybody, and so we're going to talk about them now before the finals. So sometimes when you're solving, some weird things can happen. And so we're going to see that in both of these examples, and then we'll talk about what that means. So it just means you're solving and you're doing everything right, but just some strange stuff happens that you're not sure what to do with. So you solve it in the same way. You don't worry about that. You just always solve and deal with whatever you end up with. So let's start with this first example, number 1. So normal solving, we look at it and we say, okay, we need to distribute. So we're going to distribute on the left. So we're going to end up with 12x plus 4, because we take 4 times 3x plus 4 times 1. That's 4. And that equals 12x plus 4. Well, right then you should start to notice something, but let's go ahead and follow our idea that we want to move one of the variable terms to the other side. Well, I can't pick which one's smaller because they're actually the same, so let's see what happens, and this is what's going to happen to our problem. We subtract 12x from both sides, and then what we get is 12x minus 12x is 0, and we get 4 on the left, and we have 12x minus 12x on the right, and we get, that's 0, and then we get another 4. So we get 4 equals 4. Well, what happened here is what's happening is that this problem doesn't actually depend on the variable. So it doesn't make any difference. Anything you could ever plug into x, you will always end up with something that is true. Not necessarily 4 equals 4, but you'll always get the same thing on the left that you get on the right. So it makes no difference what I plug in for x. I could plug in 100, I could plug in -1,000,000, I could plug in 7.8. Anything I plug in for x, I'm always going to end up true because the x's disappeared. Okay, so when this happens, we say that our answer is all real numbers, because now anything works for x. Okay, so we say our answer is all real numbers. So that's the first special case. Okay, let's look at number 2. So on number 2, same thing. I notice, oh, I've got to distribute on the left. Okay, so I'm going to distribute on the left. I'm going to make sure I change this to add the opposite so I don't mess up my signs, and I'm going to get -6x plus, and then I have -2 times -4, that's 8. That equals -6x plus 5. So it seems like the same as the last one, but let's see what happens. So here we know we need to get variables on one side and constants on the other. Well, it doesn't matter which one I try to get rid of. I'm going to add 6x. So we'll add 6x to both sides. -6x plus 6x is 0. So I end up with 8 on the left. And on the right, I have -6x plus 6x, which is 0, plus 5, so I end up with 5. Well, the difference here is I ended up with something that's not true. On the first example, 4 does equal 4, but on the second example, 8 definitely does not equal 5. So the variable did disappear, so it doesn't matter what I put in for the variable. In this example, I can never get anything that works. Since 8 does not equal 5, this one has no real solution. And so you will need to know about these two special cases. So if you want to watch this again a couple of times, but basically, if when you're solving, you end up with the same variable term on the left and the right. It's the exact same. So when you subtract it, you end up with a true statement. So you get some number equals some number, and they are in fact the same number. Then that means all real numbers is the solution. It doesn't matter what you put in for x, you're always going to get something that's true. Here, same thing happened as far as the variables went away, but we ended up with something that is false. And that means no matter what I put in for the variables, The variables are going to go away. That term's not going to matter, and I'm always going to get something that's not true. So that means there's no real solution here. Nothing works, okay? So be sure and write those examples down and study them in case they come up on the final. But the one thing not to do, if it comes up on the final, it might be one question. Don't say, oh, no real solution, all real solutions now suddenly on every single problem, because you don't know what to do. That's the reason I don't mention it. I don't want you to think this is common. This should not come up very often, okay? So please keep that in mind. Okay, the last two examples that I want to do on this video for solving are when we solve for a variable. Okay, so sometimes you have a problem and it just says solve for this variable, and there happens to be other variables in the problem. That's okay. We're just going to do the same solving. If I'm supposed to be solving for y, then it means when the problem is over, I want y equals. And I want no y's on the other side. That's what that means. I need the y to be by itself on one side and nothing else on the other side. So if we go to this original problem and look at it, well, there's already y by itself as far as there's no numbers in front of it except a 1, but there's this x term, and it can't be added to the y term. They're two different terms. They're not alike. So we're going to get rid of that x term. So we're going to subtract 4x from both sides. Now I'm still going to write it over here under the 11 because I don't really have anywhere else to write it. There isn't anything else on that side. But we're going to have to be careful. We still want to keep our equal signs lined up. And then you want to be careful. So we have 4x minus 4x. That's 0. So that one is gone. And I'm left with just the y. That's good. And then on the right, these are not like terms. So they can't be added any more than to simply put a plus sign between the two terms. So negative 4x plus 11. Now you'll remember we did this in one of the chapters, chapter 10, where we did all the linear equations. So that's part of the reason I chose it for these examples, just because it helps in two places. But any variable that you're trying to solve for, you always just try to get that term by itself first and then the variable by itself. So let's look at the second example. So here now I'm solving for x. So that means when I'm finished, I need it to say x equals something. That's what I'm looking for. So that means first thing I need to do is get this term over here by itself. So I need to get rid of this 4y. So I'm going to subtract 4y from both sides. Now this is two sides. There's my equal sign. So I subtracted 4y from the left and I subtracted 4y from the right. Then we're going to see what we get. So we have 3x, and then we have 4y plus negative 4y, which is 0. So now the y is not on the left anymore, equals. On the right, these are not like terms. Negative 4y and 8 are not alike, so they cannot be added any more than just to write negative 4y plus 8. They don't get combined. Now in this case, I'm not quite finished because remember, I want it just to say x equals on the left. Well, it says 3x. Well, we know how to get x by itself. We're going to divide by 3. But whatever I do on the left, I have to do on the right. There are two terms on the right. So just like when we're multiplying to get rid of fractions, we're going to divide each term. So negative 4y is a term, 8 is a term. So each of them get divided by negative 3. You always have to do the same thing to every term or you've changed the problem. Now, when we simplify what we have left, 3x over 3, well, 3 over 3 is, of course, 1. So we get 1x equals, and then here we just have negative 4/3 y plus 8 over 3. Just leave it. And then if we want the final answer, of course, we would have x equals instead of 1x, and then you would have negative 4/3 y plus 8/3. So There could be different letters, different variables, solving for different things, but you still just always follow your processes. If stuff is being multiplied by something and you want to get rid of it, you divide. If stuff is being added to it and you want to get rid of it, you subtract. If stuff was being subtracted from it, you would add, etc. Okay, so just follow those same processes. So that is our last video on solving.